El número dos. No? All right. For each sequence, decide whether it could be arithmetic, geometric, or neither, and explain how you know. So, 200 to 40, 40 to 8. Are we adding the same amount each time?
No.
No, so what can it not be?
Arithmetic.
It's not arithmetic. How would we check to see if it's geometric?
Divide the second number by the first.
We would divide the second number. When you divide 40 by 200, what do you get?
0.2.
And then what will we do to continue checking?
Do it again, so 8 divided by 40.
8 divided by 40. Each successive term divided by its previous term. And that gives us 0.2 also. What does it tell us?
0.2 is the
This one
scale
could,
factor.
this one would be the scale growth factor or the scale factor or the common ratio. So it is what kind?
Geometric.
It's a geometric sequence, or could be a geometric sequence. Then let's look at the next sequence. Goes 2 to 4 to 16. Are we adding the same amount each time?
No.
So what could it not be?
Never.
It can't be arithmetic. Are we multiplying by the same thing each time?
Okay.
How do you find out? 4 divided by 2 equals 2. Then what do? 16 divided by 4 equals 4. So can it be geometric? So you already told me it's not arithmetic.
It's not
Now you're saying it's not geometric, so what is it?
neither.
Neither, that's right. Or neither, whichever one you want to say. Second, or part C. What do you think? Arithmetic, why? Because it's adding 10 each time. 20 minus 10, right? If you don't see that immediately. 20 minus 10 is 10, then what will we do to check? 30 minus 20 is also 10. So in this case, it's arithmetic. What would the next term be? It'd be 40, right? Isn't this fun?
This is so fun.
I'm telling you, let's look at D. What do y'all think here? Is D going to be arithmetic?
Fancy. I said no.
All right, how do you know it's not arithmetic though?
Because
You're not adding and subtracting the same number each time.
Cassie said it.
Because 20 minus 100 would be negative 80.
But
And
100 divided by 20 is 0.2, and 20 divided by 4 is 0.2.
So you
Oh.
just proved that it's geometric.
all right, so you said 100 divided by 20. We've always gone the other way, but your way's fine.
I thought we were trying to say it was neither.
No. But your way's fine. Doing 100 by 20 and then 20 by 4 to see that. Because when you do 100 by 20, you get 5. And when you do 20 divided by 4, you get 5. So you said it's what, Cammie?
Geometric.
All right, let's look at the next one. What do y'all think about the next one? Arithmetic, because you're adding 6 each time. And if you didn't recognize that, you would check by doing 12 minus 6, and then 18 minus 12. Both of them equal 6. So it's arithmetic with a common difference of 6. Right?
Great job.
This is fun stuff, y'all. This one, now we get to use those rules we came up with earlier. For each sequence, write the recursive definition using function notation, and then write the function. Just the recursive definition. So let's first determine whether or not this is arithmetic or geometric. The first one, arithmetic because adding 6 each time, right? This goes plus 6, plus 6, plus 6. So we know we're adding 6 each time. So what does the recursive definition for an arithmetic sequence look like?
FN.
So we're going to say f of n equals,
In parentheses, n minus 1, close parentheses, plus whatever.
which is your common difference, right? And in ours, f of n equals f of n minus 1, and what are we plussing?
6.
Is that not the most painless thing you ever did in your life?
That's actually really easy.
I mean, it's so much fun, right?
And that was a recursive.
Recursive.
Those
You-
are arithmetic recursive.
Arithmetic recursive, this is the general form for the arithmetic recursive. This is the answer for this problem.
Alright, so it's only asking that if it's only asking for function notation. Correct?
Well, it's just telling, that's the f of n and f of n minus one,
Okay.
okay?
But that's what all recursive is.
For this and this, yes.
So if it's asking for another one, it would usually just be A of n.
You can call it whatever you want. You can call it C of n for Cammy,
Oh,
right? I can call it J of n for me, right?
yeah, it doesn't matter.
Yeah, yeah. All right, so this next one, what do we think about this next one? Is it adding the same thing every time? So it's not arithmetic. What do you do to 2 to get 14? So you know that you multiply by 7 here, so you could try and say, it's 14 times 7 equal to 98.
Yeah.
Ah, let's multiply by 7 again. And it's 98 times 7 equals 686.
Yes.
Yes. So if we're multiplying by 7 each time, what kind of sequence is it?
Geometric.
And a geometric recursive definition looks like f of n equals the previous term. What do we do to the previous term for a geometric sequence?
It's gonna be to the power, like, when it, oh, it's just multiply.
Multiply times
7.
7 in this case, right?
I'm getting confused with those.
No, you're doing good. Yeah, this is the recursive. That always use the previous term. So in our case, it's going to be f of n minus 1 times 7, because in general, f
Oh,
of
that's
n,
easy, both the recursive are just plus or multiply.
yes, times your common ratio r, right?
Test, I'll ace it before I color.
Well, I mean, I'm guessing, I haven't looked at the test, but I'm guessing that this might be on the test some, right? That's your answer for this one. The next one, let's look at this. 160, 80, 40, 20. What's happening? By 1/2, you're multiplying by 1/2 or 0.5, you could use 0.5, right? Multiply by 1/2 each time. Half of 160 is 80, half of 80 is 40, half of 40 is 20. So our recursive definition is going to be,
Oh, so it's f of n equals f of n minus 1 times
0.5 or 1/2, right? Whichever way you want to write is fine. This is so much fun, y'all. We've got us another 7-minute video going, so I'm going to stop the recording. Right?
Okay, I have a question. Stop.
When I stop or before I stop?